and welcome to the 4.07 Limiting Reactants Honors Lesson. This is the teaching video. These are the Common Core standards that we are going to be applying to this lesson. The lesson objective is pretty simple. We are going to calculate the amount of excess reactant left over in a reaction. In order to do that, we must have mastered, absolutely mastered, all of Module 4 so far. If you have not absolutely mastered 4.06 and or 4.07, please go back. Basically, 4.07 honors is just 4.07 with more stoichiometry. Yes, we are going to be doing more math. There's really not anything new to learn. It's just doing different types of math problems. More stoichiometry. Remember, with limiting reactants, it is when we're given the exact amount of both our reactants. There is a flowchart that we can use to solve limiting reactant problems. This is not set in stone. You don't necessarily have to follow this, exactly the way that it is, but if you're having trouble, you might want to. This will definitely help. So with limiting reactant problems, remember that we have to have a balanced equation. We need to make a list of what we know and what we're solving for. If you have a problem that gives you specific amounts of two or more of your reactants, you have a limiting reactant problem. Then we set up two stoichiometry problems. We're going to start each one with the reactant, and we're going to convert to the same unit of the same product. We can use our conversion factors such as molar mass and molar ratio to convert whatever we need. And whichever reactant produces the least amount of product is the limiting reactant, and the amount of product it produces is what we call the theoretical yield. So how much of your product do you produce? That's your theoretical yield. The other reactant that we don't run out of is what we call the excess reactant. All of this should already be familiar. I know I went through it really quickly, but all of this is from the 4.07 regular lesson. So if I lost you already, you really need to go back to 406 and 407 regular and learn those lessons first. Here's our general flowchart. We can use it if you wish. Some students like it, some students don't. It's up to you. It does help you understand where to start and where to finish. For limiting reactants, generally we'll just have to do it twice. We'll have reactant number 1 and we'll be converting to a product, and then we're going to have reactant number 2 and converting to the same product. Pause this recording and complete this on your own on a sheet of paper, scrap paper at home, and when you have gotten as far as you can get, hit play to resume this recording. Let's get started. So it says, what is the theoretical yield of water? And so that means I'm looking for water. If 35.7 grams of HF, so that's this one, 35.7 grams, reacts with 28.5 grams of silicon dioxide. So we're going to, since we're given two reactants and we're given specific amounts of each reactant, what I have to do is set up two stoichiometry problems. I'm going to start with 28.5 grams of the first reactant, and then in my second problem I'm going to start with 35.7 grams of my second reactant. And now I'm just going to do the first one, do one at a time. So 28.5 grams of silicon dioxide, put my X, put my line. Whatever unit I start with, that's the unit I have here, which I knew that because step 1 says to divide by the molar mass, and we know the molar mass is the mass in grams of 1 mole of your substance. The mass of silicon dioxide is approximately 60.1. When you look up on the periodic table, you have 1 silicon, 2 oxygens, add that all up. We're left with moles. We don't need moles, so we're going to keep going. Whatever unit you have on the bottom, on the top there, that's the unit that we're going to put on the bottom here. And now we're going to do the mole ratio. And the mole ratio says that we're going to multiply moles of the chemical we're looking for, which is water, and we're going to divide that by moles of the chemical we started with. That makes sense because our units have to cancel. Remember here, mole ratio is from your balanced equation, so that's your coefficients. Water has a coefficient of 2, silicon dioxide has a coefficient of 1. And we're solving for theoretical yield, so we actually need to convert moles of water, which we just did, to grams of water. So we have moles of water here. We see that we're going to multiply by molar mass, which we knew that already. We know molar mass of water is 18 grams per mole. And then we're going to go ahead and put in our equal sign because we're left with grams of water, which is what we were looking for. We're going to plug this into our handy dandy calculator and we get 0.0527 grams of water. That's how much I can make if all of my silicon dioxide reacts. What we don't know is if I have enough HF for this reaction to occur. I have to have enough HF. That is why we have another stoichiometry problem down here, and we're going to see how much hydrofluoric acid it would take to make the water. So we start with hydrofluoric acid. We're going to put the molar mass on the bottom, which is approximately 20.01. Our grams of hydrofluoric acid cancel. We're left with moles, so we're going to put moles on the bottom here. We can use our mole ratio next. Moles of HF to moles of water. I know that water has 2. Our hydrogen fluoride, or hydrofluoric acid, has a value of 4 in the balanced equation, so we're going to put a 4 there. That unit cancels. Remember, with limiting reactant problems, you must always go to the same unit of the same product. So you will notice that after a while you're going to see a lot of similarities with your problems. It takes up a lot of space on your paper, but a lot of the calculations are the same numbers. So when we plug this into our handy dandy calculator, we get 0.0496 grams of H2O. Now what we want to do is look at our products and see which reactant produced the least amount of product. This is the least amount of product. Therefore, my hydrofluoric acid is my limiting reactant. So if this problem asked me what is my limiting reactant, I would say hydrofluoric acid, HF. The problem asked, though, what is the theoretical yield? So the theoretical yield of water is 0.0496 grams. We don't have enough silicon dioxide to make this much water. And since HF is my limiting reactant, my silicon dioxide is what we call the excess reactant, which means we're going to have some of this left over. And you got it. We certainly can calculate how much we have left over. Now we're going to get into the honors portion of that question. Remember, that question we just did was actually from 407 regular. You should have been able to do that before this recording. How much water will we produce? Remember, that's our theoretical yield. And that is what we just solved. That was 0.049 grams. What was the limiting reactant? Well, the limiting reactant was HF. What was the excess reactant? The ER, the excess reactant. That was SiO2. How much of the limiting reactant will we use? This goes on your understanding of what a limiting reactant is. Recall that a limiting reactant is the reactant that's completely used up. Therefore, we're going to use all of it. In this case, it's going to be 35.7 grams of HF. How much of the excess reactant will we use? Well, we don't know that from the information given. I have to calculate it. So if you ever need to know how much of the excess reactant will remain, you have to figure out how much you use. So what we do is we can start from the limiting reactant, 35.7 grams of HF, and we're going to convert this to grams of the excess reactant. Okay, so we're going to convert to grams of the excess reactant, which is SiO2. And that will tell us how much SiO2 we need. So we're going to do grams of HF. So our molar mass of HF was 20.01. We have moles of HF. Put that on the bottom here. We have moles of SiO2 up top, because that's where we're going. HF in the balance equation had a coefficient of 4. Silicon dioxide in balance equation had 1. Our moles of HF cancel. We have moles of SiO2. We're going to convert to grams, so we have to have the molar mass of SiO2, which is 60.09 grams. And now what I'm doing right now is, remember, I started from grams of my limiting reactant, and I'm going to convert to grams of my excess reactant. And what that does is it's going to tell me how much of my excess reactant I need. So this means I'm going to use 26.8 grams of SiO2. Okay, so 26.8 grams of SiO2. So the last question, how much of the ER, the excess reactant, will remain? Okay, well what we have to do is we started with 28.5 grams of SiO2. How much did I use? Well, I used 26.8 grams of SiO2, and if we subtract those, we will get what's left over. So 28.5 minus 26.8, so I have 1.7 grams. So I get 1.7 grams of SiO2 will remain. Please pause this recording, do this problem, get as far as you can, and when you're ready to resume, hit play and we will work it out together. Welcome back. The best thing to do with these problems is to figure out what you know and what you're trying to solve for. How much of the excess reactant remains if 25.4 grams of aluminum, so that's this one, 25.4 grams, reacts with 25.4 grams of HCl? Uh-oh, I have the same amount of both reactants. So what I have to do first is I have to figure out which one is the excess reactant, which one is a limiting reactant. So what we have to do is we have to convert both reactants to the same product to see which one will form the least amount of product. So to determine what is the limiting reactant, we start with the first reactant. We're going to convert to the product. So we get grams of aluminum. Molar mass is always grams of 1 mole of your substance. Don't forget that. So 26.98. We have moles of aluminum. We need to convert to a product. Now for this problem, it didn't ask me about any product, did it? Therefore, I get to choose. Convert to either product, it doesn't matter. I'm just going to pick hydrogen, seems easy. Look at my balanced equation. I see that aluminum has 2 as a coefficient, hydrogen has 3. I have moles of hydrogen, and since I'm not asked for grams of the product, I can stop there. So 25.4, we can do all this calculation. 25.4 divided by 26.98 times 3 divided by 2, and we get 1.41 moles of H2. Now that is if aluminum is a limiting reactant, that is how much hydrogen I'll be able to produce. Now we have to start the second stoichiometry problem starting from the other reactant. So whatever unit I start with, the same unit goes down here. Molar mass is always of 1 mole. HCl has a molar mass of 26.46. My units cancel. Put an X. Moles of HCl goes on the bottom because that's what I have up top here. I'm going to go to the same product. Remember, it always is the same product. HCl has a coefficient of 6. My units there cancel. And now we just plug this into our calculator. and we get 0.47 moles of H2. You look at your answer, we were able to produce the least amount of hydrogen gas from HCl, which means HCl is my limiting reactant. Since I know what my limiting reactant is, now I can figure out how much of my excess reactant will remain. So my excess reactant is my aluminum. There are a couple of different ways to do this part. I like to start with my limiting reactant, 25.4 grams of HCl, and I'm going to convert to grams of my excess reactant. Again, that is not the only way you can do this, but I find to do this, that's the easiest. So 1 mole HCl, we know that the molar mass of HCl is 26.46. Grams cancel. Whatever unit I have on top, I put that same unit down here. My excess reactant is now going to go up top because I'm trying to find out how much of that am I going to use. This unit cancels. Now I'm going to convert moles of aluminum to grams. I know my molar mass of aluminum is 26.98. Molar mass is always of 1 mole. And now I'm going to plug this into my calculator. I'm going to multiply everything on the top, and we're going to divide by everything on the bottom. And you should get an answer of 8.63 grams of aluminum. Now that doesn't tell me how much I have left over, so be very careful. That is how much I'm going to use. Remember, we have to take how much we had to start with. Okay, we started with 25.4 grams. We used 8.63 grams, and now we subtract them. Okay, start with minus use equals left over. And we get 16.77 grams. And we're going to report our final answer as 16.8 grams of aluminum will be left over. Problem number 3. Once again, go ahead and pause this recording, get as far as you can in this problem, and then hit play to resume. Welcome back. How many grams of calcium phosphate? So how many grams of calcium phosphate can be produced when 54.7 grams of phosphoric acid, 54.7 grams of phosphoric acid reacts with an excess of calcium hydroxide? So that's an excess. What that means is that I'm already told the limiting reactant. Right away, this is my limiting reactant. Guess what? This is a standard 4.06 regular lesson problem. This should be super duper easy for you at this point, because all we have to do is convert grams of phosphoric acid all the way to grams of calcium phosphate, and we're done. How amazing is that? Phosphoric acid, we have to calculate the molar mass of phosphoric acid. All right, we have 4 oxygens plus 1 phosphorus plus 3 hydrogens. And our molar mass is 97.974 grams. H3PO4. Remember, molar mass is always of 1 mole. That unit cancels. That unit cancels. We have mole of H3PO4 to mole of our product, which is Ca3PO4 2. We look at our balanced equation. We have 1 mole of that to 2 moles of that. And then I know we have 1 mole of this chemical. To grams. Now our grams are 310.17 grams of our chemical. This unit cancels. Put an equal sign, even though I don't have quite enough space to write it there. We're going to multiply everything on the top. We're going to divide by everything on the bottom. And when we do that, we get an answer of 86.5 grams of calcium phosphate. So 86.5 grams of calcium phosphate. Once again, they told us what the excess reactant was, therefore we know what the limiting reactant is. We always use a limiting reactant to solve for how much of our product we need. Please pause this recording, work out this problem as far as you can, and when you're ready to resume and see how to work it out or to check your answer, hit play. Welcome back. When we look at this equation, we see that it says unbalanced equation. Therefore, we need to balance it real quickly. Since balancing reactions was covered back in 4.02, I am going to go through this rather quickly. If you need more help with balancing equations, please go back and watch the recorded video for 4.02 and attend our live teaching and tutoring sessions that we offer each week. So on my reactants, I have 1 zinc as my product, I have 1. Ag is my reactants, I have 1. As my products, I have 1. Nitrate, I have 1 as my reactants, I have 2 on my products, which means I need to have 2 on my reactants. All I can do is put a big number out front, but don't forget that changes the number of silvers and the number of nitrates. So now I have 2 silvers, 2 nitrates. I need to get my silvers balanced. I can put a 2 out front, and we are balanced. So we now have a balanced equation. The problem says if 2.5 moles of zinc react with 2.5 moles of silver nitrate, how many moles of zinc 2 nitrate can be formed, and how many moles of the excess reactant will be left over? So we have 2 questions that we need to solve for. Right, how many moles of this, and how many moles of the excess reactant? So we're going to have 2 answers. Since we are given the exact amount of both reactants, we do have to solve 2 stoichiometry problems. So we have to start with the first reactant, 2.5 moles of zinc, and we're going to convert to moles of our product. And then we're going to stop because the question asks how many moles of our product can we form. So I'm going to put moles of zinc on the bottom. I'm going to put moles of my product, which is zinc 2 nitrate, on the top. I'm going to look at my balanced equation. Zinc 2 nitrate. I don't have any coefficients, therefore it is 1. My moles of zinc cancel. I'm left with moles of zinc 2 nitrate. Therefore, I multiply everything on the top. I divide by everything on the bottom. So if all of my zinc reacts, I will form 2.5 moles of my product. Since this is a limiting reactant problem, because I'm given an exact amount of both reactants, I do have to do another stoichiometry problem. I'm going to set it up the same way. I already know that zinc has a coefficient of 1 because I just did it. I'm going to put moles of my starting chemical down here. I look at silver nitrate, has a coefficient of 2. And so we see that my units cancel here. I'm left with moles of zinc 2 nitrate, which is good because that's what I needed. And now I take 2.5 and I divide by 2 and I get 1.25. I can form the least amount of zinc 2 nitrate from my silver nitrate, therefore this is my limiting reactant, which makes this my excess reactant. Since my limiting reactant is silver nitrate, I can form 1.25 moles of zinc 2 nitrate. This is the answer to the first part of the problem. This is how many moles can form, and this is my theoretical yield in moles. How many moles of the excess reactant will be left over? Whenever we do that, what I like to do is I start with my limiting reactant, and I'm going to convert my limiting reactant to my excess reactant. So I'm going to have moles of silver nitrate on the bottom, and on the top I'm going to put the moles of my excess reactant. Remember, once you know your limiting reactant, start there and you can convert to anything. If I wanted to know how much silver I would produce, I could calculate that as well. Look at my balance equation. I see zinc has a coefficient of 1, silver nitrate has a coefficient of 2, so I'm going to convert that, cancel those units, and we see that I'm going to have 1.25 moles of zinc. Now remember, this is how much I'm going to use. Okay, 1.25 mole of zinc used. To figure out how much I'm going to have left over, I have to look at how much I had to start with. So to start with, I had 2.5 moles. Okay, so 2.5 moles was to start. 2.5 moles. I used 1.25 moles. So if we do 2.5 minus 1.25, you know what we get, 1.25. Then we're going to have 1.25 moles left over. Now we have our two answers. Problem number 5. Please pause this recording, get as far as you can on this problem, and when you're ready to resume, hit play. For this problem it says if we have 75.6 grams of lithium metal reacting with 42.5 grams of chlorine gas in a synthesis reaction, how many grams of the excess reactant will be left over when the reaction is complete? Well, I don't have a balanced equation. They're giving me information about two reactants, therefore I must write a balanced equation. I know lithium metal is lithium, chlorine is diatomic. When lithium and chlorine form a synthesis reaction, we have to look at their common charges. I see lithium and chlorine both have a 1 charge. Lithium is +1, chlorine is -1. Therefore, they're going to form a bond in a 1-to-1 ratio. If you don't know how to do that, you do need to go back to lesson 305, 3.08, and module 4 at the beginning, 403, 404, 405, because we did teach you how to write synthesis reactions. We need to balance the equation. I have 2 chlorines on the left. I now have 2 chlorines on the right, and then to balance lithium. So we have 75.6 grams of lithium, 42.5 grams of chlorine, and how many grams of the excess reactant? So I have to have grams and the excess reactant. I do not know which one is a limiting and which one is the excess, so I have to figure that out. I'm going to start with my first reactant, 75.6 grams of lithium. I'm going to go ahead and convert that to my product. So I have lithium. The molar mass of lithium is 6.94 grams of lithium. And remember, that's per mole. That's grams. I have moles of lithium. Whatever unit you have on top there, that same unit goes down here. Moles of lithium, and then up top we're going to have moles of our product. We look at our balanced equation, we see it's a 2 to 2 mole ratio. Since we have moles of lithium chloride, we don't need to have grams of the product because we're just trying to figure out what the limiting reactant is. Therefore, we can put an equal sign here, and we can multiply everything on the top, divide by everything on the bottom. We get an answer of 10.83 moles of lithium chloride. And now we have to do another stoichiometry problem starting from 42.5 grams of the chlorine gas. So now we have grams of chlorine. We have to have grams of chlorine on the bottom, so that's our molar mass from the periodic table. We know molar mass is always of 1 mole. that cancels these units. Mole of chlorine gas will go on the bottom. Moles of our same product at the top. Look at those coefficients. And since we're only trying to figure out what the limiting reactant is, we don't have to convert to grams of our product. We can go to moles of our product. And this shows that we have 1.19 moles of lithium chloride. So from this I can see that chlorine gas will form the least amount of product. Therefore my chlorine gas is my limiting reactant and my lithium is my excess reactant. So the question asks how many grams of the excess reactant will be left over. So first I have to figure out how much of my excess reactant am I going to use. So I'm going to start with my limiting reactant, 42.5 grams of chlorine gas, and I'm going to convert to grams of my excess reactant. And grams to grams is always a three-step process. I hope you've noticed that by now. Okay, and then we have moles of chlorine gas, and we're going to go to our excess reactant. Remember, we're trying to figure out how many grams of my excess reactant will I use. So look at my balanced equation. We see those cancel. I have moles of lithium. Now I can convert moles of lithium to grams of lithium using its molar mass, 6.94 grams of lithium. And so I'm going to multiply by everything on the top, and then I'm going to divide by everything on the bottom. And I get 8.32 grams of lithium used. Please be careful. A lot of students solve this, circle this answer, and then say they're done. And it's not, because the question is how much is left over, not how much is used. We just had to calculate how much is used in order to find out how much is left over. Because remember, we start with, we use, okay, we subtract how much we use, and that tells us how much is left. Okay, so start with, we had 75.6 grams of lithium to start with. We subtract how much we used, and that will tell us how much we have left over. So notice this is the same type of math problem over and over and over again, just starting from one chemical and then you finish to another. But there's molar mass and molar ratio. There's only two conversions that you need to know how to do in order to do pretty much a million trillion different types of problems. It's all the same type. All you have to be careful of is those vocabulary words, you know, excess reactant, theoretical yield, moles, grams, limiting reactant, and understanding that to solve for how much is. Thank you so much for joining us. It's been great working with you on stoichiometry, limiting reactants. It's super important for the rest of Module 4, the segment exam, and segment 2. If you're doing segment 2 with us, you need to be able to do stoichiometry for Module 5. We're going to take stoichiometry and add algebraic formulas to it. Now they're not hard formulas, so don't panic, but we need to be able to calculate grams to moles and moles of one chemical to moles of another. Thank you so much and have a great day.